Hi everyone, welcome to this presentation. My name is Sam and I'm a Senior Solution Architect at AWS. I also have Soyam here and we are both analytics specialists at AWS helping customers across different industries to successfully go through their analytics journey. Today we are going to talk about how to build the next generation of enterprises, or what we call it event-driven enterprise, using AWS streaming data services. Let's look at what we are going to cover. We are going to have a quick overview of enterprises and their digital journey. Then we will talk about event-driven enterprise and the required capabilities to make it a reality. We will also cover different architecture patterns that are leveraged by our customers across different industries for event-driven use cases. And finally, we will discuss some of the key considerations that you need to examine when choosing a specific type of AWS streaming data service. All right, let's start talking about enterprises and their digital journey. Enterprises in all sizes across different industries are going through their digital transformation journey to drive better business outcomes and stay competitive in the market. We have enterprises in industries such as mining, telecommunication, logistics, energy, and financial services trying to adopt digital technologies to transform their services and businesses. With digital technologies replacing all their manual processes, we are seeing enterprises start to produce large variety of high-speed data, which if you have a closer look, they are because of events across the enterprises. We have enterprises in asset-intensive industries such as energy or mining who invested on IoT technologies to monitor and detect critical events related to their asset operations. Or some enterprises across financial sector or retails implemented mechanism to capture customer interaction events with the enterprises app to provide better personalized experiences to customers. This story is the same for data that is captured from social media events or application logs. This high-speed event data is named as data stream, which provides a lot of insights around events happen across the enterprises if they are properly analyzed. Now, let's talk about analytics as the key enabler for enterprises to accelerate their digital transformation journey. Enterprises can be at different maturity level in their analytics journey. The analytics maturity level is based on enterprise capability to use analytics to drive their business processes. To better demonstrate this, let's have a closer look at this analytics maturity model. As soon as an event occurs in an enterprise, like operation state of an asset changes or a customer clicks on a link, the stream data related to these events can be originated and captured in close to real time. But the analytics may happen after a while, and as you can see, the business value that can be brought by analytics can depreciate over time. Depends on the time that analytics is done, we can put the enterprise at different analytics maturity level. Some enterprises are at basic analytics maturity level. These enterprises do analytics very late down the track. They just use ad hoc analytics capabilities such as spreadsheets or dashboards for reporting purposes. The second analytics maturity level in this model is data-driven maturity level. In this analytics maturity level, enterprises move analytics closer to the time that the data is originated. They leverage advanced analytics capabilities such as big data and machine learning to drive their business processes and get more value. The next level of analytics maturity, which can help enterprise to use the most of analytics, is where analytics is performed as soon as the stream data is originated. In other words, as close as possible to the time that the event happens. We name this level of maturity as event-driven for the enterprise, which is the topic of today's presentation. In this level of maturity, enterprises leverage stream data technologies and automation to make operational decision-making and drive better business outcome in close to real time. The aim of this presentation is to show how AWS can help enterprises become more event-driven. Now, let's see how we can make enterprises more event-driven. As mentioned in previous slide, streaming data technologies are the key enablers to integrate real-time event data or stream data from a variety of sources. There are 4 key capabilities that need to be leveraged to help enterprises be more event-driven. Firstly, the data from different event sources such as mobile, clickstream, or even IoT devices need to be ingested into the platform. This requires the ability to scale a solution that can capture data coming from hundreds of thousands of sources in a reliable manner into one stream for analysis. Additionally, the ingested data is then need to be stored in the order it was received for a set duration of time and can be replayed for downstream applications during this time. Stream storage is the capability to address these requirements. As the data is stored in the stream, it can be processed by real-time applications to generate real-time insight. So stream analytics is the third capability to help enterprises be more event-driven. Finally, to execute real-time data transformation and then deliver the continuous stream data to a destination such as data lake or data warehouse, stream integration is the fourth capability needed for enterprises to be more event-driven. Developing all these capabilities can help enterprises to drive different business outcomes such as automatic decision-making or interactive dashboard to have a real-time view of enterprise operation. Alerting and real-time machine learning are other types of insight that can help enterprises to better deal with their critical events such as anomalies. Now, let's talk about why enterprises should use AWS streaming data services to become more event-driven. There are several key differentiators for AWS streaming data services for real-time applications. Firstly, AWS streaming data services are easy to use. It just takes a couple of seconds to provision these services within AWS console. Secondly, AWS streaming data services support seamless integration. So if you are already on AWS, you can easily integrate these services with your existing AWS services and workloads. We also support open source tools such as Apache Kafka and Flink, so these services can work with the plugins which are built by open source community. In addition, you can use AWS streaming data services in a fully managed fashion, which means you do not need to think about managing infrastructure. And also, you just pay for what you use. Security is job zero at AWS, by which we mean it is an integral component of AWS services. So AWS streaming data services are secure and compliant, which can help you build your real-time workloads with peace of mind. We have several services that can help you make your streaming data workloads secure. At the same time, AWS streaming data services are also compliant with several industry-recognized certifications such as HIPAA and PCI. So far, we discussed why and how enterprises can be event-driven. Let's see how you can build the key event-driven capabilities using AWS streaming data services. In this slide, we have raw stream data from sources in one side and the noted event-driven outcomes in the other side. Let's see how you can convert these raw stream data into value and outcome for the enterprise. As we mentioned before, you need to build 4 key capabilities to become more event-driven: stream ingestion, stream storage, stream analytics, and stream integration. For a stream ingestion, you have several options in AWS. If you are dealing with IoT data, you can use AWS IoT services to ingest the data into AWS platform. Kinesis Agent is another option to be used to ingest data to Amazon Kinesis. You can also use AWS SDK to have full control on the way of ingesting data to AWS platform. Also, Amazon Database Migration Service can be used when you want to stream data changes in a database to AWS platform. Finally, Kafka Connect is the option if you want to stream data to Apache Kafka workload. In terms of stream storage capability, you have two options on AWS: Amazon Kinesis Stream and Amazon Managed Streaming for Apache Kafka. And you can choose either of these two services based on your use case and requirements. We will have a slide to better help you understand how to choose stream storage service. For Stream Analytics, again, you have several options, including Amazon Kinesis Data Analytics, AWS Lambda, Amazon EMR, and AWS Glue Streaming. Again, the choice depends on the use case and requirements. Finally, you can use Amazon Kinesis Firehose to integrate stream data into your data lake, which can be on Amazon S3 or your data warehousing on Amazon Redshift, or even your search service on Amazon Elasticsearch. Overall, this slide shows a holistic view of services that can be used to build event-driven use cases on AWS. As you can see, you have several options for different capabilities, and the good thing about AWS is that you can start quickly with those based on your requirements. In the following slides, we provide some example use cases to help you better understand how to use these services. Now, to better demonstrate how you can architect your event-driven use cases on AWS and show you how easy it is to use AWS services for event-driven use cases, let's talk about some common architecture patterns for enterprises and how they can be implemented on AWS. There are 4 common use cases that we see our customers across different industries are leveraging AWS streaming data services to become more event-driven: IoT, Clickstream, Log Analytics, and Change Data Capture, or CDC. Now, I want to pass this to Sayam to talk about these patterns and how they can be implemented using AWS streaming data services. Over to you, Sayam.
Thank you, Sam. Hello, everyone. Thanks for joining our session today. Now, I want to talk about some of the real-world pattern, and also will give you reference architecture to solve a specific business problem with AWS services. First, start with IoT. IoT data enables industries like logistics, telecom, mining, oil and gas, and energy to react on inefficiencies and problems sooner, saving time and money and supporting business intelligence efforts. Use cases like asset monitoring, supply chain optimization, fleet management, and proactive quality assurance are key initiatives for success on those industries. For example, doing predictive maintenance by continuously monitoring the equipment, keeping the right inventory can help avoid any unplanned production outage. Let's imagine a use case. You want to build an asset monitoring system for industrial assets, so you can quickly respond to changing conditions, identify operational trends, and improve forecasting to maximize the performance and efficiency of the larger system. In this example, you use a feature of AWS IoT Core, the IoT Device Gateway, to ingest data from connected devices. Then the AWS IoT rule sends those data to Kinesis Data Stream and Kinesis Data Firehose. You use Kinesis Data Firehose to ingest data to Amazon S3, so you can analyze and visualize device performance using Amazon Athena and Amazon QuickSight. The AWS IoT Core also sends those data to Kinesis Data Streams. You use Apache Flink on Kinesis Data Analytics to run real-time aggregation to understand whether a device temperature is breaching a certain threshold, and then send those process data to another Kinesis Data Stream to generate real-time alerting using AWS Lambda and Amazon SNS. Let's move to the next pattern, Clickstream. Clickstream events are a small piece of data that are generated continuously at a high speed and high volume, mostly generated by user actions. There are a wide range of industries can benefit from analyzing Clickstream data. For example, retail, e-commerce, advertising, media and entertainment. Use cases like campaign optimization, tracking customers' online journey, real-time upselling and cross-selling by identifying a customer. All those can be improved by analyzing clickstream data in real time. For example, you can detect user behavior in a website or application by analyzing sequence of clicks a user makes, the amount of time user spends, where they usually begin the navigation, and how it ends. By tracking this user behavior in real time, you can update recommendation, send push notification, and much more. In this second example, let's build a reference architecture so you can analyze clickstream data and identify user sessions in real time. In this example, you are capturing clickstream activity from websites and mobile application. You are using AWS SDK to ingest those data immediately to Kinesis data stream. Once the data is available in Kinesis data stream, an Apache Flink job hosted in Kinesis Data Analytics perform aggregation logic for sessionization of clickstream data, which analyze event per hour, visitor count, and ingest those data in near real time to Amazon Elasticsearch to visualize with Kibana. The Kinesis Data Firehose ingests the data in real time to Amazon Redshift, which helps to build a recommendation engine with Amazon Redshift application programming interface. So you deliver a personalized content. In addition, you keep storing those data to Amazon S3 for ad hoc analysis using Amazon Athena and build a machine learning model using those data. The third pattern I want to discuss today is log analytics. Log analytics involve searching, analyzing, visualizing machine data generated by IT systems and technology infrastructure to gain operational insights. Moving your log analytics to real time can speed up your time to information, allow you to get insights in seconds or minutes instead of hours or days. There are various different problems you can solve by analyzing log in real time, like real-time application and infrastructure monitoring, root cause analysis, security intelligence and event management, and clickstream analytics. By analyzing log, you can quickly identify the root cause of the issue across your environment, which helps to reduce the downtime and increase availability of your application. For example, Netflix use Kinesis data streams to process multiple terabytes of log data each day. They can discover and respond to issues in real time by analyzing the logs to ensure high availability and a great customer experience of their platform. In the third example, I'm going to talk about my own experience working with a customer to build a log analytics platform. In this example, the customer have web servers running on Amazon EC2. They configure Kinesis agent on all of their instances, which helps them continuously forward web server log record to Kinesis data stream. Then they use Kinesis data analytics with Apache Flink to aggregate dataset every minute and output that data with inbuilt Flink Elasticsearch connector to send data to Amazon Elasticsearch service. Then they use Kibana to visualize those log data. At the same time, they use Kinesis Data Firehose to write each log record to Amazon S3 for durable storage of raw log data. The major benefit they are getting in this architecture is fully managed and the end-to-end stream processing pipeline is serverless. The final pattern I want to discuss today is Change Data Capture or CDC. Back in the days, we used to use one single data store for all purposes, like transactional and analytical workload. Things has changed. Now we understand using the right tool for the right job is very important to build a cost-effective, scalable, and highly available platform. We want to build additional feature. We want to share data across multiple domains, do parallel data processing for various different needs without impacting the core platform. And we want to integrate with heterogeneous system. One of the way to achieve all those is by re-architecting the existing platform. But re-architecting existing platform is not easy. It's complex, costly, and time-consuming task. The quickest way to evolve your existing platform without impacting the core system is capturing data changes from your transactional system in real time and start building new capabilities for features on top of it. Now, the final example, I'm going to tell you about an Australian large enterprise where they utilize AWS service to build an event-driven platform without breaking the existing core component. The customer is running their core transactional system on Amazon RDS Postgres database. So they use AWS Database Migration Service to continuously capture transactional logs from Postgres database, which send those transactional logs to a Kafka cluster running in a fully managed environment on Amazon Managed Streaming for Apache Kafka or Amazon MSK. They use Apache Flink on Kinesis Data Analytics to read from Kafka topic, process it, and send it to Amazon DynamoDB to build a low latency, scalable API frontend for their internet-facing application. They use AWS Lambda to build a trigger-based system, which continuously monitor a Kafka topic and send alert using Amazon SNS when it requires. They also use Apache Flink S3 connector on Kinesis Data Analytics to replicate data from their transactional system to Amazon S3 Data Lake. As you can see, they build all those additional features without changing anything on their core application. So far, we discussed about real-world use cases, how you can make your enterprise more event-driven, and what are the AWS services that you can use to build that. Now, I want to explain a bit more about some of the AWS services we have introduced here. The first thing is about streaming storage. Streaming storage is distributed in nature, provide ordering guarantee and replayability of your data. At AWS, we have two different managed streaming storage services, Kinesis Data Streams and Managed Streaming for Apache Kafka. In Kinesis Data Stream, you provision your resource by creating shard. And in Amazon MSK, you provision a cluster with one or many instances. So you pay based on the resources that you provision in both systems. In terms of scalability, Kinesis Data Stream can handle or scale within a second, where Amazon MSK takes minutes based on the compute resource that you choose to provision. It means you get more throughput by adding more shard in Kinesis Data Stream and by adding more broker or instances in Amazon MSK. Kinesis Data Stream provide 3x durability of your data out of the box, and you can configure up to 365 days data retention. In Amazon MSK, it's very flexible, and you can apply your own desired durability and data retention settings. The latency is configurable in Amazon MSK, for example, by changing minimum in sync replica. For Kinesis Data Stream, you get 70 millisecond or lower latency with enhanced fan-out feature. Kinesis Data Stream provide native AWS API support and also has integration with many open source tools like Apache Beam, Apache Flink, Apache Spark. And Apache Kafka on Amazon MSK has a large open source ecosystem support. So we talked about streaming storage. Now let's discuss about using the right streaming analytics tool. There are various different tools you can use at AWS for analyzing real-time data. For today's discussion, I want to focus on three major AWS serverless services in this space: Kinesis Data Analytics, Glue Streaming, and AWS Lambda. For connecting with various different source and sync, Apache Flink on Kinesis Data Analytics and Spark Streaming on AWS Glue has many inbuilt connectors. Not only that, both systems provides rich support for complex data operation like windowing, aggregation, and joining. With AWS Lambda, you have to write your own code, especially to build a sync connector. However, if your dataset are not that big, you okay doing simple analytics with tumbling window, AWS Lambda is a fantastic option for analytics on Kinesis data stream. In many use cases, data correctness is very important. And with exactly once processing capability on Kinesis data analytics and AWS Glue streaming, you will be able to achieve it as long as your source and sync provide exactly once result guarantee. With AWS Lambda, you have to implement your own logic to do that. In terms of scalability and latency, both Kinesis data analytics and AWS Glue can handle large-scale stream processing with a very low latency. With AWS Lambda, if you are processing single record at a time and running simple transformation, you will be able to achieve low latency at a very high throughput. With that, now I believe you have more idea what services to choose when. Before I hand over to Sam, I want to let you know some of the recent major announcements we had on real-time data streaming services. With Kinesis Data Stream, we added support for 1-year data retention. You can use a single KCL application to connect with multiple streams. And schema registry support with AWS Glue schema registry feature. For Kinesis Data Analytics, we added support for Flink 1.11 and Python support, and also improve Flink producer for Kinesis Data Firehose. On Kinesis Data Firehose, we added support for archiving messages from Amazon SNS, delivering data to any HTTP endpoint, and other destinations like MongoDB, New Relic, and Datadog. On Amazon MSK, now you can do vertical scaling by changing the instance type. Also, we added support for Kafka version 2.7 and schema registry with AWS Glue. In addition, you can use AWS Lambda as a trigger for your Kafka topic. And we have added cruise control support on Amazon MSK, which makes topic partition management and cluster monitoring easier than ever. With that, now I'm handing over to Sam for his closing thoughts.
Awesome. Thanks, Sayam. So now, to conclude the presentation, let's review what we learned. We discussed why enterprises need to be event-driven, how they can be event-driven, and how AWS can help in this journey. If you want to learn more on this topic, I highly encourage you to follow our Big Data blog, which includes a lot of materials around how to use AWS streaming data services for event-driven architectures. Also, you can check out our Data Lab program if you need any support from AWS technical experts in designing and building your event-driven use cases and accelerate your data and analytics modernization initiatives. I'll also include some more links related to Amazon Kinesis and Amazon Managed Streaming for Apache Kafka, so you can learn more about these services. You joined the AWS Summit to learn, and you can keep the learning going after the summit with resources from AWS training and certification. We offer many free and on-demand digital courses as well as virtual instructor-led training. AWS expert will help you or your team learn to build and validate your data and analytics skills. When you are ready, prepare for the AWS Certified Data Analytics Specialty Exam, which validates your skill and provide an industry-recognized credential. For more information, visit aws.training/analytics and be sure to check out our AWS Ramp-Up Guide to learn more. That brings us to the end of this presentation. I hope you found what we have shared with you all to be of use and interest. And I look forward to you using AWS streaming data services to build your event-driven use cases. Please also remember to fill out the survey for this session. Thank you very much.